Okay, I'm starting, yes?
Yes, please, please.
So it may be make more dimensional, yes?
This is better.
Yes.
Okay. So welcome to participants of this session of our conference. Thank you very much to organizers of this conference for our invitation to this session now on our speech. So we'll consider today multi-attribute decision-making interactive model based on the well-known body of evidence theory and fuzzy discrimination hybrid approach for the creation of dependable and reasonable applications. And we'll consider as an example application of our approach in emergency psychiatric diagnostics. So it is very important timely servicing demand points and persons which are in the disaster-stricken zones, disasters which maybe happen by some natural catastrophes or on the results of hostilities and so on. So the basic in these problems is logistic planning problems and medical emergency medical planning problems and other things. And in the whole service, the timely servicing is very important. We'll consider some new approach method for the creation of dependable intelligence supporting systems, which may be applied in emergency psychiatric diagnostics for the victims, which are in such as regions in recovery phase of the planning of emergency problems. So a new interactive math approach based on evidence theory and fuzzy discrimination analysis is developed. Multi-attribute decision-making utilities or expert evaluations will be presented in so-called Kurang orthophoria fuzzy values as some extensions of Zadeh's fuzzy sets theory. This presentation will be involved in the Debster-Schaeffer belief structure environment and Debster's external expectation and as an aggregation instrument for the ranking of optimal, for the ranking of all possible alternatives or selection of optimal alternative under discrimination, Kurang orthophoria fuzzy information also will be developed. So extending a numerical example it will be presented in the problem of emergency psychiatric diagnosis. So the speech will cover the following main problems on attributes interaction phenomena in such as problems. Usually when we have several attributes in decision-making problems on which some attributes or state of nature acts in the decision-making process, it is sometimes we have such as cases where these attributes are in the interaction environment. So these phenomena will be considered for in the process of construction of decision-making models. Debster-Schaeffer belief structure. Debster-Schaeffer belief structure is some extension of probability statistical theory on the one hand, and on the other hand, of the so-called possibility theory by Zadeh and other authors. And we have some extensions of this method of this theory in the temporal environment. So we don't consider temporal case. We consider only static case or Dr. Schaefer structure. Sometimes which this theory is unique in the evaluation process of complex nature problems investigation, where the unique information source is expert and his her knowledge. So new extensions of Dempster's extremal expectation as an aggregation operator also will be developed in the environmental Dempster-Schaefer belief structure, and attending numerical exam will be also considered in the environment of emergency psychiatric diagnostics. So our goal was to use Dempster's extremal expectations as an aggregation tool in multi-attribute decision-making models. Let C will be some pair of Courant or Hoffer fuzzy numbers. If in Zades fuzzy sets, we know that we have only single levels of uncertainty. In such a case, we have as two units, and the first phi indicates of the assignment in the membership of degree, and the second phi indicates on the non-membership degree. But by the following inequality, this inequality has some freedom in the selection of the choice of these two pairs, where Q will be some minimal number which satisfies this equality. It is clear that this form of presentation of expert activities in the process of solution on the evaluation of possible alternatives with respect to some attributes will be more convenient, because we'll have here more intellectual activities using Courant-Hoffer fuzzy. Courant-Hoffer fuzzy sets theory is developed today and is very applicable in such as problems. So let me consider in general some multi-attribute decision-making model where we have some sets of alternatives, some attributes. Also from the historical data, that we give also frequency data for this for the all alternatives with respect to some attributes by G's. So we have some matrix by frequencies by named decision-making matrix. So from this matrix, we transform this data to the so-called positive and negative discriminations measures, P and N's. What is the P? In this formula, CD is a cardinality of the attribute sets, and the gamma ratio is a fuzzy value which indicates on the fuzzy arguments value, and we have the following information hence of these two parameters. In whole, this pair creates some Courant-Hoffer fuzzy sets. The main is that it is necessary to mention that this pair is more convenient and more information than only frequencies, and attributes interaction phenomena is included in the such as pairs. So on the information has on this pair. What is a positive fuzzy discrimination? This method describes the degree of confidence that the attribute I is more relevant, indicative of the alternative G than any other attribute. But negative fuzzy discrimination indicates that this measure represents the belief, not degree, but belief that the attribute I is less relevant, indicative of the alternative J than any other attribute. So instead of the frequency matrix as a decision-making matrix, We consider matrix as a decision-making matrix by these Courant or pairs by set by D, the Descartesian product. So by the transformation and interaction phenomena between attributes are reflected by the constructed fuzzy discrimination Courant or fuzzy numbers. So sometimes the interaction of attribute is the basic, and we have to consider such as multi-attribute decision-making models when an aggregation instrument only has the possibility to consider this phenomenon. Okay, now shortly on our algorithms based on the Debter-Schaeffer belief structure. You know that from the statistical probability theory, we have mass or some frequencies or elementary probabilities on the elementary events, if we consider finite case of probability theory, okay? But sometimes in complex environments of the experiments, not random experiments, we have such situations where not electrons, but some subsets of events can some information with respect to possible data, possible analysis, possible alternatives. So this mass is called in this theory as the focal probabilities, and if this focal elements as which has some information by strongly positive masses of so-called focal probabilities, if this pair is called Debter-Schaeffer structure, where these BGs are singletons by its probabilities. In this case, we are in the probability environment. Sometimes we are in the possibility theory environments. Sometimes we are in the hybrid environment. So in general, when our evaluations or statistical samplings are based on the knowledge experts' evaluations as a unique source of information, in such as cases, not probabilistic, but Debter-Schaeffer belief structure is a unique instrument or unique possibility to describe informationally, quantitative informationally, this process with respect to decision making. So let me give some in our problem some Debter-Schaeffer belief structure by M and B focal elements. So we consider now the ski one by the following steps. Create decision-making matrix based on frequencies of the previous history in fuzzy discrimination decision-making matrix as a Courant of fuzzy numbers matrix. Create a focal elements which have some information in the mass as a focal probability in our problem. So we consider only focal elements, some sets of our states of nature, which has only strongly focal probabilities, okay? On the following step, we determine the weight of each attribute and weights of focal elements. On the following, we build the unity collection as a set of frequencies on the focal elements. After this, we select some aggregation operator, and by this aggregation, in the aggregated benefits, we aggregate information of these frequency sets. So calculate the expected predictive value. We calculate CGs as a weighted sum of the aggregated benefit by the weights in the roll of weights. We'll use focal probabilities. And the end step, we rank alternatives from the optimal to the less optimal by their discrimination values, CGs. So this is the simple presentation, simple case of our approach, how we can select optimal selection based on the Delta-Schaefer-Billy structure. The freedom in our procedure is how we can aggregate aggregation function. Now we go to on this problem. So in this presentation, I define so-called Debster's extremal expectations. The upper expectation, DLE, the lower expectation. Please, it is necessary to mention that this is some weighted sound on the focal elements, frequencies, or utilities values by weights the focal probabilities. It is clear that for every decision or for alternatives, this pair creates some orthophase number. Let us construct an extraction of these aggregation operators in the discrimination environment. And this discrimination will be the new presentation in which will be presented attributes interaction. And this extension will be good aggregation instruments when in decision-making problems always exists attributes interaction. So this extension presented by these two formulas for the DUE will be extension by the large ratio function, by mass or focal probabilities, and they have the pessimistic, optimistic ones, extensions, or lower and upper expectations of Dempster. So now on the application or constructed our scheme, where in the role of aggregation we will use Dempster's expectations and its extensions. So we will have two possible aggregation results in the prediction of diagnosis of some patients in future. Now we go to on the ending our problem of my presentation, application of these two expectation aggregation tools and their extensions in the emergency psychiatric diagnosis. So the population affected by the disaster has many problems, yes. One of them is quick medical assistance. Among them, there are many psychiatric disorders caused to citizens in a stressful environment. Early groups that are recruited to help the population may not include qualified psychiatrists. In order to create the necessary preventive diagnostic environment, appropriate supporting medical diagnostics, dependable and resilient emergency decision-making intelligence system must be able to reduce the number of victims, also maybe reduce some materials and other resources of this environment. It is necessary to construct tools for effective aggregation of interactive attributes of different types of decision in order to make extreme optimal decisions. It is clear the software based on our approach technologies should be involved, which will be focused on minimal medical examinations. So our developed methodology can be considered as a model of such a support system. We will consider the example of emergency psychiatric care in an extreme situation using the decision-making model built in this work. So we consider based on some previous historical true decisions dealing with the or alternatives as a psychiatric diagnosis. We consider three such as alternatives here, and this and possible attributes as symptoms we'll consider here, and these are some frequencies which are calculated based on the information from the information center of the State Psychiatric Clinic of Georgia. So based on this decision-making matrix as a matrix of frequencies of true decisions as a true decisions to file to diagnosis with respect to activities of symptoms is considered. So on the basis of this expert information, we created some focal elements by the symptoms which individually act on the possible decision or on the possible diagnosis. So we selected such as way only for such as types of focal elements where some symptoms are included here, and maybe some symptoms may be included in several symptoms. So maybe these focal elements may be jointed. And we have also, on the basis of their experiments and experience, weights of these symptoms. And after this, we evaluated focal probabilities of focal elements. So in general, we created the Depth-Schaeffer belief structure of such a type of problems, and now we consider, based on this knowledge information, we consider some disaster region and some persons which are included here. And for this, we consider everyone from this as a patient. We'll consider some activities of our method for the make optimal recommendation as a optimal diagnosis selection. So let's consider the patients from some victims. For these patients all presented groups as focal elements are characterized symptoms groups. Otherwise, we have to take in the decision aggregation scheme only such as focal elements which are characteristic for the concrete patients, or such as focal elements which act on the decision process of decision-making selection. So table 3 shows the calculations obtained by the two methods of aggregation described above, and the rank data of optimal diagnosis for this patient. So we have here that if we use a standard or classical pair of Depth-Schaeffer expectation, we have the following ranking, and the F20 diagnosis is more optimal than another. Also, for the extension of these expectations by our aggregation operators, also is ranked this diagnosis, and in this case also this F20 diagnosis is optimal for this patient. But now we on the comparison of rankings. As we can see, the optimal diagnosis in both aggregation cases is paranoid schizophrenia, so F20 0. However, second and third order diagnoses are different from each other, and this indicates different approaches to aggregate it. See, please. So second and third levels of diagnosis, we have some differences. As mentioned above, this difference is due to the existing of the phenomena of interaction of symptoms as attributes of the model. So, understanding, it is clear that for each patient whose data and expert evaluations will pass the scheme creates above, it will be possible to predict the diagnosis in the environment of the constructed scheme, but taken into account only such focal elements which are characterized for the concrete patients. At the conclusion, in this work, the phenomenon is reflected in the fuzzy discrimination parameters introduced in the Dempster-Schaeffer belief structure environment in the aggregation of Dempster extremal expectation. The difference of the new aggregation from the classical Dempster segregations of extremal expectations is presented in the numerical exam from Diagnosis of Emergency Psychiatry. In order to develop future studies, the fuzzy discriminations will be embedded into such aggregation operators which take into itself account attributes interaction phenomena. For example, Choquet aggregation integrable or Suggero integrable environment and so on. Thank you very much for your attention. So, questions, please? Sure.
Thank you for your presentation. Please, questions.
Yes.
Does somebody have questions? So I do not see. So I do not see the presenters of the fourth report. So my question to Professor Serbiladze is, are you ready to give the last report at our session just now?
Which slide?
No. I mean, are you ready to give the next report?
Yes, of course. Yes.
Okay. No questions.
No, it seems to me no.
No questions. Okay. Thank you.